Right now, so we're going to be covering problem 3342, find minimum time to reach last room 2. So there's a dungeon with n cross m rooms arranged as a grid. So we've already done the first part in the previous video. Now we're going to be solving a slight variation of this problem. We're given a 2D array again, move time of size n cross m, where move time ij represents the minimum time in seconds when you can start moving to that room. You start from room 0, 0 at time t equals 0 and can move to an adjacent room. Moving between adjacent rooms takes 1 second for one move. Yeah, so this is the key difference here. Moving between adjacent rooms takes 1 second for one move and 2 seconds for the next move, alternating between the two. So what it means is that when we are moving to adjacent rooms, we take 1 second for one move, and then the next move we take 2 seconds. Then again for the third move, we'll take 1 second. Then for the fourth move, we'll take 2 seconds, and we keep on alternating between these two. Now again, our task is the same, returning the minimum time to reach the room n-1, n-1, right? And we can either move horizontally or vertically, so only 4 directions, up, down, left, and right. So as you can see in this, so this is the problem 0, 4, 4, 4. So this is the grid that has been provided to us. What we need to do is, firstly we'll wait for 4 seconds to pass so that we are able to access either of these two cells. So once this has been passed, we at time is equal to t is equal to 4, we move to 1, 0, that is this cell. But now when we're moving to this cell, we would take not 1 second, we take 5 plus 2 seconds to move, because that has been given to us in the problem that we take 2 seconds in the alternate move. So the final answer comes out to be 7 seconds. Now in the next example, you can see we have 0, 0, 0 and 0 here, and 0, 0. So basically a 2 cross 4 matrix, right? And all the values are 0. So we can move from here to here, we take 1 second. Then we take, for the next move, we take 2 seconds. Then for the next move, we take 1 second. And then for the next move, we take 2 seconds. So you see 1 plus 2 plus 1 plus 2, that comes out to be 6 seconds, right? And the output is 6. So that's how you solve this problem. Now let's get to the coding part. So the logic is simple. We're going to be, again, we need to find the minimum time. So therefore we'll apply the shortest path algorithm, that is the Dijkstra's algorithm here. And we'll be storing our basically parameters in a priority queue or minimum heap. But the addition from the previous problem here in this problem would be that we'll also have to keep a check for a flag, which would check whether we are basically moving for 1 second or moving for 2 seconds. So that flag would have to be there. So let us start. Int n is equal to move time dot size. This is the number of rows, and m is equal to move time dot columns. Sorry, dot move time of 0 dot size. This is the number of columns. So this is rows and this is columns. And what else do we need? We need to have we need to basically be setting a priority queue. So priority queue of type yeah. Now the catch is here. Here we'll have to set a tuple. So using tuple t is equal to tuple of int, comma int, comma int, comma int. Since we're going to be storing 4 values, so let me just define those values. So firstly, we'll obviously be storing the time. Then we'll be storing the x and y coordinates, that is the row and the column. And here we'll also be storing the flag. So let me name this flag as what can we name it? Let us just say it's flag only, right? So what is our flag doing here? So the flag would basically be to alternate between 1 second and 2 second, right? So this flag would alternate between these two. Now we can easily set the priority queue vector of type t and greater, because we're going to be using it for a minimum heap, right? So this is a minimum heap, right? And our aim is to basically get the minimum time to reach the bottom right cell. So let me, and the name, yeah, let me add the name as well. Let us say it is pq. So we'll first push the value of what is it, move time, right? So first we'll set it as 0, and we're going to be sending this time here first, then the x and y coordinates where we're starting from, that is 0, 0, and also the flag. So what is the flag value here? We'll set the flag as 1 initially, right? Because we're starting from 1 second, and then we'll alternate between 1 and 2. So once we've done this, we can move to our standard algorithm for the Dijkstra. That is, while our priority queue is not empty, we set auto current is equal to pq dot top, and then pop the element pq dot pop. Then int time is equal to, our time would be the current of 0. Then similarly the 4 values, that is our x coordinate, then our y coordinate, and finally our flag, right? So current of 1, current of 2, and current of 3. So once we have set these, now we can move on to checking first if in case x equal to n minus 1 and y equal to m minus 1, which means that we have reached our bottom right cell, reached bottom right cell. So here we finish our algorithm, and that is we return the time. Now we're moving on to our actual algorithm, how we are going to move to each step, move to each cell. So for auto and d directions, so directions is basically a 2D array. Let me declare that vector of int type 2D array directions. So this is the standard in all problems I've discussed. First we take 1 comma 0, which would be left, then we take minus 1 comma 0, which is right, then we have 0 comma 1, which is up, and 0 comma minus 1. In vertical we are moving minus 1, which is in the negative y-axis, but in horizontal we have 0, so this is down. So this is our directions vector vector, and we basically say in next row is x plus d of 0, and next column is equal to y plus d of 1. And now we check if in case this is valid, if is valid, that is if the values of the cell, or basically the x and y coordinates of the cell, that is n, r, and c, are in the bounds of our grid, that is move time, then only we'll proceed, otherwise we won't. So let me create this function, that is bool of is valid. It will return either it is valid or it is not. So int I comma int j, int n, and int m, right? So this is basically we're going to check for these four parameters. So if in case I greater than equal to 0 and I less than n, and j greater than equal to 0 and j less than m, then in this case we're going to be saying that we return true, because this is in bounds, otherwise it would be out of bounds, so we return false, right? Now we can continue with our algorithm. So now we also need to declare move cost, that is basically 1 second or 2 seconds. So as I declared here, a flag that would alternate it. So int move cost is equal to uh, basically if the flag is true, then if the flag is true, then we have the move cost as 1, otherwise if the flag is false, we have the move cost as 2. So this is the ternary operator. So this means that if the flag is true, then move cost would be 1, otherwise if the flag is false, the move cost would be 2 seconds. So that's the cost. And now we can say int our arrival time, or the next time, would be the time that we reached our next cell. So that would be the current cost, that is the time, plus the move cost. You understand that we are taking the time plus the move cost, that the time that we have already stored, right, that we're getting from our priority queue, and the move cost, that would be basically 1 or 2, right? That would depend on the flag. So the flag would keep alternating, and we can basically set the flag after every iteration. We can change the flag, right? Right. And the next time would be the basically the maximum of the next time and the time that we have, right, after adding the move cost. Next time would change definitely. And now we can basically say that the flag would be updated, right? So next step is equal to 1 minus flag, right? Let us say this for the flag, and after this we can just say what we need to do is we just need to push pq dot push the four values that we have, that is the next time, our next row, next column, and our next step, which is basically the flag that we have, next step flag, right? And if this is not happening, then we return just -1, right? So let me submit and check. Okay, so we are getting an error here. Time does not provide a subscript operator. Okay, so in a tuple we cannot do this, right? So let me just also another thing that I had to confirm here, that we have to take the move time, right? Since we are considering the grid timings, not the time that we have chosen, so the move time would come here, nrnc, right? That's one correction. And another correction is that we cannot do this because we are taking tuple type here. So how do we deal with this? We basically just take it in this format. Sorry, not this. We take the square basis and say auto time comma x comma y comma flag, right? And then we try to run it. So yeah, you can see we're getting a wrong answer here because there's a few things that I have to correct here. So basically what we also need to do is we need to implement it using dp, right? So I'll show you how we get dp here. So we basically need to get dynamic programming. So we'll use a 3D vector. So vector of int type dp, and n would be basically the number of rows, vector of int type again. Within this we again have m columns, and then vector of int type which would have basically, now there are two values, right, of flag. So we also need to, since the flag is also a variable parameter here, so it could either be 1 second or 2 second, right? So that is why we have to store binary value. So we take 2 here, and the values you can set as int max, right? So that's how we declare the dp. And what would dp of I comma j comma the flag value, or the parity of the step. So let me write flag only. What would this denote is basically the minimum time required to reach our cell I comma j with the uh, flag alternating between 1 second or 2 seconds, right? So this is the variable parameter, and since x and y are also changing and the flag is also changing, we have taken a 3D vector of for dp, right? So this is one thing that we have to add here. Now since we are starting at basically 0 comma 0, so we take the start time as uh, this value, which is, sorry, this is move time. So we have this dp of 001 would be move time. Since at 1 second we have the uh, initial movement, right, for 1 second, then it alternates. Also we have to put a check here that if our current time, that is f of time, greater than dp of x comma y comma flag, then we have to continue, because we have already stored it, and the time, if that is greater, then we have to just break out of it, right? So let me just correct this. Also here we have to check that if our next step is less than dp of nr nc, and what is the flag, sorry, if next time is less than the next step, here would be next step, not next time, and here is next step. So if in case our next time value is less than the value that has been stored, then only would we push this inside, and we store the uh, value inside the dp as this should be the next time. And now let us try. So the error is that okay, move time, and we're getting a wrong answer. Okay, so I found out the error. The error is that we are mutating this move time 00. We're setting it to a different value. So we don't need to do that. Instead, what we have to do is we have to choose our start time differently, not change the value of move time. So that is not advisable also. So we take the max of these two values and use this value here, right? So that's a better form of coding. And let us now check, right? So 10 test cases have been passed, and again we're getting it wrong. Also another thing, this is the error, I think, that we haven't even set the value of dpxy flag as time. So we again forgot that in the last video also. This is the most important condition. This is the very critical condition that we often forget, and I think that is why the wrong answer is coming. So let me just try this. I think we have to first wait for this move to happen. So we have to wait first, and then we have to take our movement forward. So let us see if this works. So wait time plus move cost. Move cost is this value, right? And next time, okay, next time I have redeclared. So let me submit this, right? So we have to wait first, I think, and then we have to make the move. Okay, now we are passing 503 test cases. Again we are facing some. Okay, let us try something that I think where the error is coming is using this start time only. So let me just try using this, and let us see. And yeah, it has been accepted. So I think this was the error, that we have to keep the start time initially that was coming, like the 25 that was being shown to you in the grid. That start time we have to store, but in the priority queue we have to push 0, since we have to start from 0. And here we are taking the max. So here only the main error that was occurring in this part only. The whole algorithm was correct, but this part is the trickier part. And yeah, that's it about the video. So I hope you guys liked the video, and